Hello people. Today I am sharing a set of video animation models and accompanying workflow for LTX 2 that I have been working relentlessly on for the past several weeks, training dozens of models, building all types of workflows, and looking at thousands, literally thousands of clips until my brain has bled. But nonetheless, I'm finally happy with it, and so I'm here to share it. You can download it for free on Patreon. If you're not a member, consider subscribing. The free tier unlocks everything, and if you're watching on Patreon already, thank you. Before I dive into this, I want to give a big shout out to Palm from Banadoko, the Discord server. There is a microgrants program that is new where people who are interested in training models can submit a request and have an agent almost immediately provide financing for training projects like this. While the grants are micro, having a way for a community to quickly access funds to rent high-end computers to do high volume training for projects like this that have really heavy foundational models, and to make that level of financing, while small, quickly accessible to people who otherwise have consumer grade hardware. I've never seen anything like that where there's a grant program that is designed to be like rapid fire small grants where you can apply online and immediately get finances into a crypto wallet. Like, this is one of the most forward-thinking, community-facing, generous things I've seen. Once again, huge thanks to Palm and Banadoko. If you're not on Banadoko, it's a great Discord server. Check it out. It has super deep layers of all types of workflows and models and the people who are keeping up with this stuff and making art and technology. And anyways, onto this project. So what you're seeing here is the result of a ComfyUI workflow with a series of LoRAs, and it's a video-to-video process with a control map using the Canny edge guide as well as a reference image. So when our intention is to make something that the base model can't make on its own, it's a lot of data manipulation. And so this video-to-video process, to get this result, the best method that I found, and I tested about everything I could think of, was to use 4 different LoRAs in a chain instead of just one on the dataset. And so instead of training a single LoRA on balance noise, I was able to get this aesthetic by training one LoRA on high noise, which is like training on just the motion, training one LoRA on low noise, which is training more or less just like the style and the texture. Also training a LoRA on stills on a different data set of images to kind of stabilize and add a certain level of like sharpness that gets lost in the model trying to learn motion. And then also using the detailer model to add like fractality and pixels between the pixels, if you will. So this is the Comfy workflow that was used to create the animation. And there's a lot happening here. I'm going to go into the nitty-gritty parts of it later in the video because I just want to touch on the most important part first and share the results before I do all the technical stuff. And that is this LoRA pipeline. And so here we have 2 LoRAs that are affecting the image the most. And then we have a LoRA that's trained on stills. And then we have the detailer LoRA, that's the stock LTX one. And so the inputs that were used to create this video were, this is a first and last frame, like a photoreal thing I just made quickly of a guy's face melting. This is the video input that was used to make the video, which the control net is extracted from. It's the most important part of determining what the structure of the video is. Ultimately, the line work or the depth map here is what we can force the model to align to. This is the image guide that is used in conjunction with the video plate, and it's just the first frame of the video that I applied a style transfer to. This is what it looks like if we were to just run the workflow with the base model only, using the guide video and the image together with no extra LoRAs. And as you can see, there's all this weird nacho cheese dripping on his face, and the coloration is completely different from the background, and the textures look really confused, and there's all this weird artifacts going on. It's pretty horrible, and that's because the base model is trained on realism, and then here suddenly we're giving it this graphic illustration and a long confusing prompt, and it's trying to mix all these different styles, and it's ultimately getting really confused because it's sampling from too much data. This is the most successful output with a chain of models together that we're going to work backwards from to talk about how we got here. If we were to use the exact same chain of models, a high noise, a low noise, a stills model, and a detailer model, with all the same settings, but just not using the guide video, this is what we get. And so that guide video is really important in determining the structural integrity of the subject matter of what we're trying to capture, especially with models like this that are trained and used so aggressively that if you don't give it something to adhere to, it will really completely rip it apart. And so this chain of models is not designed to be used on text to image because it really needs a video structural support. So if you were training a model in AI Toolkit and you set up your whole config, the default for time step bias is called balanced. And that means that the model is learning the high noise and the low noise with an equal weight of importance. The high noise is where the model learns things like composition, and in video particularly, it's more important because it's how the model learns movement. The low noise is more things like color and texture and style. There's a lot of overlap between these. It's not a perfect stop and start, but ultimately a model that's trained on high noise is going to capture more emotion, and a model that's trained on low noise is going to capture more texture. A balanced model is the default model. Most models that you're using are going to be trained on a balanced time step bias. The biggest discovery in this research I had was to get the model to learn the motion and to also tune how much of the style comes through, was to, instead of training one balanced model, to split the training and have a model trained on high noise and a model trained on low noise, with all of the data set and all of the config otherwise matching the exact same. For example, if we were to train on a balanced model and I just switch the high and low noise with balanced, this is what we get. And it's still arguably not bad, but this really doesn't have the style and the structural integrity and the cleanness and the smoothness of the motion that is in our master shot. And so this is a good step in the right direction, but ultimately a way to get more control out of the video is to have a model in high noise, a model in low noise, and then you can choose by turning up how much of the high noise model do we want, how much are we influencing the motion of the data set the model is looking at versus how much are we looking at the texture of it. And by having these two split, it allows the user to have a lot more precision in tuning the aesthetic, and that it's not just the texture, but it's also the way that things change and move in the frame. In addition to the high and low noise models, and I know this text here might look a little bit confusing, but ultimately it's just a truncated version of the file name of the model that designates how it's different from the other models that are in this folder that I have. And so you can see that both of these are non-quantized models. Both of these have a batch size of 1, a gradient accumulation of 4. They're trained at 250 steps each, and the high noise is operating at a strength of 2.25, and a low noise is operating at a strength of 2.5. There's also a LoRA that is trained on stills, a different data set. That's a similar style, but it's not the same. And then there's a LoRA that is the stock LTX IC detailer LoRA, and that's also helping us get some detail retention back amidst all the crazy motion that's happening underneath the hood. If we were to just look at the high noise by itself, and instead of having the second model be a low noise, I just swap it with the high noise, now what we're seeing is there's no color separation, and that's because the model isn't learning color. There is background motion, there is morphing of shape in the changing. We lose the subject retention because those identity details are something that's in the low noise pattern. But what we do understand here is that the model understands the motion. With no detailer, with just the base model, with no stills model, the model understands that, okay, things need to morph and bend and wrap around each other and melt. And so that's what's captured in the high noise. So when we turn up the high noise model, this is essentially the channel of artifacts that we are influencing. And here's the low noise model. The low noise model, we could actually understand the color palette of this data set. We can understand that it's a 2D data set. We can understand that there's black outlines that separate the colors from each other. We can see there's a uniformity of where the colors land on the color palette and they stay consistent through the shot. We can see that things are pressed against each other and there's no gradients and there's no shadows and there's nothing that's transparent. So what the model has learned here is a little bit of the motion. You can see how things are kind of morphing around and kind of changing, but ultimately what's really captured here is the texture and the color and the rendition at a more pixel level. And so this is a great way to illustrate the difference between high and low noise, is just looking at what happens when we have models that are trained on high noise. We have the motion captured. What happens when we have models trained on low noise? We have a little bit of the motion, but we also have the color and the texture. And vice versa, these things, as I said before, it's not like one is only motion, one is only texture. The high noise is also going to capture some of the texture, and the low noise is also going to capture some of the motion. By separating them, we allow ourselves more control of determining how much of each do we want. And so this is the high model, the high noise, with the low noise, with the LoRA trained on stills, without the detailer, just those three together. This is walking it back even further, going just the high noise and just the low noise. And so if we stack these on top of each other, essentially what we're looking at is the difference between what happens when we add a model that's trained on stills into the pipeline. And at a first glance, the difference isn't big, but as you zoom in, you can really tell that Now this is just the high and low noise. But when we add the model that's trained on stills, the patterns that form are a lot more coherent. The line work is a lot more solid. The differentiation between colors is a lot more defined. The video models together, the two LoRas trained on video, do a good job of capturing the motion and the aesthetic of what we're looking for, but it really loses the subject retention and the identity of the shot. And so having this model that's trained on stills functions similar to how the detailer works, but not the same. Because now what we'll see is that the detailer model gives us a lot of fractility. We turn on and off the detailer, we can really notice the difference here. And we still keep the motion that's in the high noise and the low noise of the models, but we just give a lot more clarity to the subject. And so this detailer LoRa, I have it turned up to a strength of 1.5, is really helpful in this pipeline because these models are operating at such a high strength that it needs these extra models in the pipeline to kind of balance out the chaos that we're causing. So here's the high and low noise only, here's the high and low noise with the stills, and here's the high and low noise with the detailer. This is just the LoRa trained on stills. We can see that it's less photoreal than the original base model image, like this nacho cheese thing that's pouring on his face. It's still not quite the right texture, but it's more in the right direction. There's no motion really happening. It looks confused on whether things should be moving or blowing in the wind, and that's because this model is trained on stills. And so this model hasn't learned any of the motion. It's just learned like a cartoon graphic texture. It has preserved the line work, it has preserved the forms, and that's because this model has a really good understanding of structures and faces and objects and things. And that's another thing that the stills model helps with, is this preserving of the details. The detailer model really adds a certain level of fractility. The stills model, as we can see here, kind of melts the style together and helps the base model understand that if we're not looking at motion, what we're looking at is still not supposed to be photoreal. And then here's the final. And this is using the Canny control net. If we were to run all of the exact same settings and use a depth control net, we would get this. It's just a different look. I think the Canny control net holds a little bit more of the original image. The depth control net tends to hallucinate more, which I also like. It's just a little bit different part of a taste. The other thing I've done here is I've upscaled it. And so we do have a little bit of artifacting and some blue halation on the edges here, but ultimately this is the original output that came out of Comfy. And we can see there's just a lot of artifacts and color tearing and things like this, and I'll show this workflow later, but this is the upscaling workflow. It's all open source, it's SeedVR2, you don't have to buy anything except the compute, and it really cleans up and smooths a lot of this junk out that's hiding in between the pixels here. And we get a lot more of this too when we use these intense models. We're more likely to have artifacts, and so this upscaling step isn't just to enhance the resolution, it's also to smooth the color areas. And the other thing that's important, and this is a really small detail, is when we have our master and we're ready to upscale it, is to export it in ProRes. And that's because, again, ProRes is a form with less compression, there's less artifacts. This is the MP4 H.264 that comes out of Comfy. I know we have to zoom in really small to see these details, but these artifacts are more likely to occur with these really intense LoRAs, and so we're going to try to do everything we can to reduce them, and one of those is just the codecs we use. The ProRes files are a lot bigger. The ProRes HQ is the most high you can go with the 8-bit outputs that come out of the models. The 444 is technically a higher color bit depth, but there's no actual gain there. It's just creating data that doesn't actually do anything. So ultimately the ProRes HQ is going to give us a cleaner image as well. And that's something else that we can do just to make this look a little nicer before we upscale it to ultimately just bring a cleaner, more polished look. All right, if you're still following along, congratulations, and it's time to dive a little bit deeper into this workflow. Now that we understand a little bit more about how these models work together, that there's a high noise at strength 2.25, a low noise at 2.5, then we have a stills LoRa, and then we have a detailer LoRa. I'm just going to go and really quickly run through all of these nodes. So here at the top, we can enable and disable all of the LoRAs in case we want to see what it looks like with just the high noise or just the low noise or whatever. We have the type of control net we're extracting, either depth, Canny, or pose, and then we can also save the video to ProRes, or if we're having dialogue and we want the dialogue in the original video to come out of the video with lip sync, enable dialogue will make that happen. This is the parent folder that we're saving to. This is the path that's inside of that folder. It's duplicated, so whatever you put here is going to be the name of the folder and the name of the file inside of that folder to keep things organized. And then here, so you can see that string exported there. The best settings to use this LoRa because of the training data and LTX and where they converge for 16:9 is 1433 by 768 at 24 frames a second. The frame load cap You shouldn't be doing more than 121 frames if you want to get the best out of this model, because both the LoRA and LTX2 is trained on 5-second clips at 24 frames a second. That's 120 frames. You can do longer. There are a bunch of hacks to it, but ultimately the best results and the most control and not having to wait long time for a render to see that all 20 seconds of it aren't what you want. The best results for control and for quality are going to be doing 5-second clips that are 120 frame batches. This is where you load the video. This is where you load the image. You can leave this tech to false if you want it to ignore the image. This is where you control the seed. I have it fixed here for all the tests so that we're using the same level of randomness and we're not changing anything. This is where you put the prompt. This is where the video comes out. If you save it ProRes, this little green box gets enabled. If you want to use manual sigmas, you can turn it to true. I have never found it to give me better results, but I put it there because I know some people like to use it anyway. I think there's probably some special use cases for it, blah, blah, blah. This is where the model is loaded. We're using the non-distilled 19B dev version that goes with the LTX2 audio VAE, the text encoder. Before anything happens to the video, I have a set of segmentation nodes that separate the person from the background, but you can also separate anything from the background. If you have a flower blooming in the field and you want to isolate the flower, you can type flower. I'm going to talk about how these masks will come in handy later, but ultimately we're going to get a mask of the foreground and an inverse mask of the background. That same video is going to be passed into pre-processing. The pre-processing is going to downscale the image by 50%, and then we're going to upscale it with a second pass of the sampling. That's standard for all of the X models. I've also tried this with different resolutions, doing no downscale and only upscaling, or upscaling more and then, or downscaling more and then upscaling iteratively. I've tried combination of latent upscaling plus the LTX upscale model. I wasted a bunch of time doing this stuff. The downscale to 50% and then 2x upscale and 2 passes of sampling, it works the best. You don't need to mess with this, so I just close this node. Whether you choose depth Canny or open pose will dictate the control guide that is here. The yellow boxes to determine which control guide you use correspond to the yellow control guide type switcher at the top. Ultimately, most of what you're going to have to do is in this big purpley box at the top that's called globals. Everything else here is kind of optional if you want to get nitty gritty with it. The depth uses Lotus depth. I had better results in using depth anything too, but if you want to use depth anything, you can just switch this to true and it will give you the depth anything instead of the sampled depth map. If you use Canny, I have it on the most aggressive Canny settings to extract the maximum amount of line work from the inputs. That gave me the best results. And I use DW pose, but you can use whatever pose estimator you want. Each of these control boxes has the respected IC control LoRA to go with it that will enable and disable on the toggle, so you don't have to worry about changing the LoRA. Just change the toggle and it will change everything for you. The prompt goes through an LTX prompt enhancer. I usually had good results with this. Sometimes I toggle it off. This is something that you can choose to keep on or not. I liked what it gave me, some people don't. And then it concatenates with the trigger word of the video model and the trigger word of the stills model. If you're using different models or you train different models, you can change these trigger words so you don't have to remember to write them in every single prompt you do. But for this workflow and this chain of models, these are the correct trigger words, so this node is collapsed as well. The video we loaded is decoded with the VA, and then it's combined with the image into the LTX image to video in place node. This is part of the standard workflow. If you're using that dialogue that I was talking about before, it's also going to use the audio VAE and separate the vocals with this fill audio separation node. That's a really great one to have. It's going to do some mask to correctly size and match the latents together, and then it's going to take the image output from whichever control net you have selected and automatically pipe it into the add guide multi. And so this is where the control net goes in and combines with the video latent that also contains the embedded image of the start frame. It takes the VAE and it also takes the conditioning from our enhanced prompt and then spits out a positive and negative conditioning with a new latent. This workflow looked great with CFG 8 and 8 steps. If you're doing a more photoreal style, you could probably turn down the CFG to like 4 and increase the steps maybe even up to 20. It's using the Res 2S sampler, which in my tests look the best. If you're using manual sigmas, this is where you would set them, but like I said before, I recommend that you just leave the sigmas to the automatic version here. This is where those masks come into play. Another thing we're doing to enhance the hallucination of the model is we are injecting negative noise into both the character and the background by segmenting whether we're injecting noise into the character or the background. Just basically gives us control, because sometimes with noise injection, it looks good on things that you don't want the eye to fall to, but for someone's face, you might want less noise. And so this essentially has a higher amount of noise, 0.75 to negative, to the background and a little bit less to the face. And so this will make the background hallucinate more and have more artifacts, and it will help the face morph more while still not losing the face. And so if we were to turn this face segmented mask that's getting a latent noise injection really high, we would have more liquidification of the face, and vice versa. If we turn it to 0 or even positive, we can add more structural integrity. And so as well as having the LoRAs control how much motion we're having, we can also, in the latent pipeline, we can separate the foreground and the background, use those as layers, and then inject noise into those separate layers. This is something I really found that helped the aesthetic of this more abstract image, was injecting the latent noise. And this latent noise injection is really interesting because there's so many different parts of the pipeline you can do it at. And I tested every single knuckle where there is a latent pipe going into a node. I tried injecting different amounts of noise, different shapes of noise, different patterns of masks, and I found that amidst all of this stuff, undeniably for me, I found that the best place to inject noise for this aesthetic was after the first sampler, but before the second one. So as soon as we go through our sampler and we split the video and audio latent, then we're gonna pass it through the foreground mask and then the background mask. I have us using fractal noise, which is a really aggressive pattern. If you use any of these other patterns of noise, you'll probably want to increase, and by increase I mean lower, that makes so much sense, to lower the number so it is a higher negative value, if that still makes sense. But for the fractal noise, it's a really large, intense pattern of noise, so these smaller negative values work well. Once it comes out of our sampler, we have the same model pipeline as before, but we are using a distilled LoRA here, so now our CFG is 1. This looks the best with the upscaling. For some reason, I have no idea why. Then we load our upscale model, X2, 1.0 upscaler. I know by the time I have made this video, LTX 2.3 has came out. I couldn't get anything out of LTX 2.3 to look this good and to run this fast. So for this use case, I'm still doing everything in LTX 2. I'm sure there'll be future explorations with LTX 3, and I'm sure I'll train this model in LTX 3 in some capacity in the future, but I was really happy with what I got with LTX 2. And so I'm not going to go into LTX 3 if I don't have to. I love the new models, but I also think that it's great to use legacy options if they are functional and do a good job. Then we have the same node structure of the image in place and the K-sampler select and the noise and blah, blah, blah into our final sampler. And then we use a tiled decode if you want to use frame interpolation and render less frames and then interpolate between them. I also included the fill rife interpolation here that uses the 47 model, but I have that off because it just gives better results not to use it. But if you're stretched on compute, you could always turn the frames input to skip every other by making this value a 2, select every nth frame. So now we're basically rendering every other frame. If we were to play this sequence back at 24 frames a second, it would be twice the speed. And so if you're going to render every other frame, you also need to interpolate every other frame. And so now this is a separate model that basically sees between the frames, blah, blah, blah. I'm not going to go into interpolation. We're going to leave that off again. And then that sends our decoded frames to our save video node, which is H.264 at a pretty high compression because I'm just banging a lot of these out as fast as I can. And then when I find a good set of concoctions that I like, then I will go ahead and enable the ProRes and then run the same thing. Wow, that was a lot of talking, and I'm so excited to release this workflow and be done looking at it because I've really broken my brain trying to find the best settings. I also want to point out that this workflow, to run the full version of the X2 base model, you need at least 80 gigs of VRAM, so you can do it on an A100. It's a lot faster on the Pro A6000. Past that, it's kind of diminishing returns. So I would recommend jumping on RunPod and getting a Pro 6000 for $1.69 an hour. Each render takes between 1 and 2 minutes, depending on your pipeline. So do the math. It's still cheaper than a closed source model, and you have a lot more control over it. And if you want to run the model faster or run it on a smaller card, there's all types of quantized versions and speed optimizations out that you can find a bunch of tutorials on. I'm not going to go into it because that's kind of a whole nother realm of its own. I think for the sake of this test, I just want to see what can we do with the full version of the model. And then if you want to scale it down on your own end proportionately, I welcome you to change out the nodes, use the GGFs, use the quantized versions, or do whatever you want. Just to review one more time, the models that you need to run this workflow, and I'll put these in the description as well, is the LTX2 19B checkpoint, the LTX2 audio VAE, the Gemma 312B FP4 mixed text encoder, the LoRAs you'll need. Now, when I release this workflow and the models, they will not be named like this crazy. I'll just call it like the high noise and the low noise version of the model. But ultimately, you will need the high noise version of amorphous, and the trigger word is also the name. It's just amorphous spelled with a 3, a 0, and a 1 for the vowels. The low noise version of the model, you will also need this model I trained on stills that I will also release called graphic impressions. And then you will also need the IC detailer model. And then as far as the control net, there is a LoRa for each control net. There's a depth IC model, a Canny IC model, and a pose IC model. Once again, all of this stuff I'll put in the description, and you can download those and drop them in the correct folders. Oh wait, and there's more models. There's also a Distilled LoRA here that I forgot about, as well as the upscale model. So this workflow uses quite an array of models, and I'm sure it will be a fun mess of error messages to get this up and running, because there always is, but once it works great, and I'm happy to answer any questions or help you if you have any problems along the way. And then finally, once we have our mastered shots that we're ready to polish and upscale, we're going to bring them into this seed VR workflow, which is separate from the generation workflow deliberately, so that way you don't accidentally have to switch between loading the entire model weight of the LTX2 model and then loading the entire model weight of Seed VR, which are both huge models that take several minutes to load. And so it's really not practical to swap between upscaling and generating. It's better to do all of your generating and then on a separate machine or a separate time in parallel if you would like to do all of the upscaling. It's pretty straightforward. It uses 2 upscaling passes at 1.42 and then another at 1.42, so 1.42 squared. Whatever resolution we put in here should be roughly 1.42 our base long side, and then vice versa. This one should be 1.42x this one. Because both of these are using Seed VR, the full weight FP16 7B version, we're just going to use one loader and one VAE loader here that will plug into both of them. You can load your video here. It will automatically send the frame count to the batch size of each upscaler, and that's going to give you the best quality. If you're hitting an out of memory error, because I usually do this on like an H200 or even a B200, and so if you want to use a smaller GPU, I would just start by scaling back the batch size. This is the file path, this is the file name. I usually just indicate, what file extension I want it to be called. It will extract, whatever frame number you put here. So it will extract the 12th frame from this video, and then it will preview it, the original versus the first pass of upscale, and then the first pass versus the second upscale, and then the third window is the original versus the upscale, and you can see, and it's much cleaner and crisper in the upscaled version. One of the reasons we do it in 2 passes is because to remove those artifacts, it really helps to blur the video input just by 1 pixel with a Gaussian blur is plenty, no more, no less. And then the output from the first upscale will be a little bit too soft because of that blur, but it will have successfully removed the artifacts. And so then in the second pass, we're not going to add any blur to the input. We're just going to send the output directly from this upscaler into this upscaler. Otherwise, all the settings are the same. There's these string concatenate nodes that will just help designate the file savings and which one is the final 2x versus which one is the final 1.42x. And so that way, when you're downloading the files, instead of digging and looking to see the resolution and comparing them, it just has it inside of the file name. It's a little bit easier that way. And yeah, that's the upscaling. Here's the original, here's the upscale. And if you are getting too many artifacts still and you want it even smoother, I would recommend that the setting to change here is the latent noise, and you could just probably do this by anywhere from 5 to 10% at a time. I have it set at 0.25 for the first one, and then the only setting here that's different in the second one, I said they were the same before, I lied, is that the latent noise scale here is 1%. And so that artifact smoothing, we're able to do that because we blur the image, and then the latent noise scale basically allows the model to hallucinate where is blurry, what should it be that's not blurry. And so once we do that the first time, we don't need to do another hallucinative upscale, but we do need one just to sharpen it again. So again, 2 passes of upscale, we blur the image into the first one, we add 25% of latent noise scale, which is a lot. You could turn it down if you think it's too smooth. You could remove the blur if you think it's too smooth. And then we send that output into the second one. That does another 1.42, 2x total, 1% latent noise in the second one. Much better. I want to touch a little bit on the training I did to get to this point. And as you can see, my LoRa folder is, how many LTX LoRAs is this? I have no idea. I think it's probably close to 100. Granted, there's only 20 versions of the second data set. I also trained a different data set up to 8 versions, 9 versions. Oh, there's 22 versions. Okay, so this is 31 versions of this model split between 2 different data sets, and each version of the dataset training has anywhere between 2 and 4 epochs. So yeah, this is looking like somewhere around 70 or 80 models here to get to this point. And this is a heavy model to train. And so I'm hoping that whatever I have learned here and whatever you can take away will reduce the amount of training and testing we have to do in the future, so that I don't have to do all these tests between training balance versus high noise and gradient 2 versus gradient 4 and blah, blah, blah. I definitely had the best results coming with these key settings that I'm going to go over now in training. And that if you're training an LTX2 model, I'm just going to pretend like I'm about to train a model. Trigger word, blabbity blabbity blue, LTX LoRA. Why did I say it like that? LTX, we'll just call this a fake LoRa. Quantization, we're not going to quantize the text encoder or the transformer. For the network dimensions, once again, I tested this and it always works. I'll say this time and time again. The linear rank 128, the linear alpha 64, the conv 64, and the conv alpha 32. It always works across every architecture. I still don't understand why. It doesn't matter. It works. Data type, leave this at BF16. If you wanted to train at FP32, you could find it in the config. This is just in the simple version referring to how it saves the file. But under the train section in the advanced settings, if you wanted to change this to FP32 and train at full precision, you could. It's really slow. I tried this and my results were worse. I don't understand why that is. Hypothetically, it should be better, but thankfully it's not, because it means that we don't have to spend as much money training. And so if we are training at BF16, it makes sense to save at BF16. Because we are using this pipeline with a video input, we are going to train it to do I to V. If we train I to V, we cannot increase the batch size with this model architecture on AI Toolkit. Don't ask me why. I've tried everything I can do. The biggest batch you can do with an I to V LoRa is batch of 1. Now, if we are increasing the batch size, it means that we linearly scale down the steps we train. So when I was training on batch size 1, gradient 1, the steps I found was the best for this model, and every training run I did was 2,000 steps. So if I was going to train on batch 2, I would train for 1,000 steps. Now, increasing the batch size, a lot of times we'll max out the graphics cards on the computers we're using, even if we're using good computers, even if we are able to increase the batch size, but we're not able to increase the batch size. So what we can change is we can change the gradient accumulation, which is similar to the batch size. It makes the model learn faster, but it makes the training go slower. Now, a lot of people will say that doing gradient accumulation of 2 at 500 steps is the same as doing gradient accumulation 4 at 250 steps. I can say that's not true. You will have similar thresholds of results, but it's not the same. Both batch size and gradient accumulation increase the amount of time you have to train, but they reduce the amount of steps you have to train. I got the best results increasing the gradient accumulation. So if my target steps were 2,000 and I had the best results of gradient accumulation at 4, I would train up to 500 steps, and then I would save the version at 500, and then I'd probably save a second one at 250. This 250 model was my favorite, so effectively I'm actually only training 1,000 steps, because 250 times 4 is 1,000. But because we're doing gradient accumulation 4, we only need to train 500 steps to get to 2,000. Now, sadly, it's not a proportionate scaling of training time to gradient accumulation. And so when I did gradient accumulation 2, it's great. We only have to train half the steps, but it's more than doubling the time. It's 3xing the time. Now it's 12 seconds a step. And when I did gradient accumulation of 4, it was 6x the time. It was 30 seconds a step, sometimes 35 seconds a step. And so even though by scaling our gradient accumulation up, we don't have to train for as many steps, our training time still increases. but we're going to do that because I saw better results by doing gradient accumulation 4 and training steps 250 as opposed to gradient accumulation 1 training steps 1000. I have a whole folder of more than 2000 tests that drove me insane looking at. I'm very conclusive that this was my favorite. I'm not going to go and show you all of them because I don't want to do that to anyone, no matter how much I hate them. But I would recommend for training LTX, these anime style LoRAs, to do gradient accumulation 4, once again, 500 steps, save it twice, maybe even save it thrice or 5 times, every 100 steps if you want to get really nitpicky. So if you were to do this, you'd have 5 different models, one at 100, one at 200, 300, 400, 500, and then progressively they'd be getting stronger, and so you could test them, and then once you're overcooking it, then you could knock it down and then try the lower step count. I, moving here forward out, will probably just only train gradient accumulation 4 or 500 steps because I know that that was even too much. And so even just with 500 steps with these settings, we're going to overshoot the look a little bit. And once again, the most important thing I learned here was that the best results came from training one model high noise, copying the config, Control C, paste it into a new one, change the version number, and then just go low noise. And so then you spit out 2 models and use those in a chain instead of just using one with balanced noise. With an H200, I was not able to train at 1536 resolution. I had to get a B200 to train at 1536 resolution, but because I was not inferencing at 1536, even though my training data was 1536, because I was only inferencing at 1280, I found the best results were training up to the exact resolution that we're going to inference at, and no more and no less. And so the other thing that's important when training models, and this is tricky because if I release this model and I only intend to use it for 1280, but someone else wants to use it at a higher resolution, they might not have good results with it. Not only that, it's hard to train at these high resolution with these huge models if your training data is 121 frames a shot at 5 seconds a shot at 1080 every single shot is a ton of data to run these training processes on. Long story short is just inference at 1280 and then upscale it later. Instead of maxing out your compute with the B200 to train for 10 hours just to get one version of a LoRa times 10, you spend $400 in like a day. So you can scale down your compute and your costs a lot by just knowing what resolution you want to inference at and then not training more than that. You definitely want to train not less than that either. So again, think about the resolution you want to train at. Look at the resolution that the base model is designed for. LTX does great at 1280. And so we're going to train at 1280. We're going to have our data set be bigger than 1280, but that's okay because the model will learn in the small details. And it's not like we have to inference at that, even if we're training at that. I don't know if that makes sense either. Blah, blah, blah. We would pick our data set here that I haven't loaded because I'm not doing this for real. I always disable sampling because I'm just going to test these models in Comfy where I have full control over the noise injection and the 2 models in conjunction with each other. And it takes a lot of time. So I just take disable sampling. I X all these out. And this way I'm not wasting compute doing all these tests that are just going to be worse versions of one that I'm going to do in Comfy anyway. We're going to cache the latents. We're going to cache the text embeddings. If you're training an audio model and you have a bunch of different variations of sound, because this model also trains audio, there's some settings for audio like normalizing the levels and preserving the pitch if you normalize the levels, or if you're stretching the clips longer or shorter, it will understand that even though it's training a 5-second shot over 10 seconds, that it shouldn't half the pitch. We're not going to worry about this audio stuff because I'm not training audio because I'm neck deep in too many things to think about with video as it is now. I would love to know more about the audio world of models, but I think there's so much to catch up with video that I'm kind of just focusing on video, even though these models have audio built in, and I've tried to include some settings in the workflow for that, like if you want to do lip sync and blah, blah, blah. But once again, I'm not really focusing on that, so don't ask me about it. And we also want to make sure that our data set is all, this is very important, is all 120 frames. It's because 24 frames a second times 5, for some reason +1, there's some computer math reason why we have to +1. So when we're making our data set, you should go into Premiere or some editor or DaVinci for free or whatever you want to do and just export 5-second chunks of what you want to do. The art of making a data set, and especially the art of making a data set for video, is where most of the work happens. It's more important than all these settings. It's more important than the stack of LoRas together. The training data and how it's captions is the most important part. I will probably make a separate video on that later it's too much to go into right now, and my brain is already fried and I want to eat these potatoes. But I would recommend watching the Ostrus AI Toolkit video, who has a nice demo on training a character LoRA, where he talks about building data sets and how to make them and how not to make them and how to caption them and how not to caption them. And he kind of goes through these settings as well. I made my first training runs on LTX based off of the Ostrus recommendations because he made this software, and so I figured that he was a good starting point. He quantized the text encoder to 4-bit and says that you can do that and it's not supposed to be lossy, and I don't understand the exact trade-off, but I just noticed that when I didn't quantize this model at all, that the results were better, and I was able to train it on an H200 without any quantization, and I was able to run it on an A6000 RTX without any quantization. And so I'm just going to go ahead and put both these to none. That's another important difference that not a lot of people do, but I always see, not always, but I often see good results when I'm training LoRAs and I'm not quantizing them. Time step, I tested all of them. Weighted was the best for LTX, MSE was the best. Decay and learning rate, you can change these a little bit. I think raising the decay is good for stuff like this. I just left it at the default because I was so burnt on all the other settings, but I did some tests with higher and lower decays. The higher decays I thought were a little bit better, but it wasn't so substantial that I wanted to do all the training runs again with a different decay value. A lot of these settings you don't have to change. Some of them, like the rank and the quantization, I really recommend you changing. The learning rate and the decay you can play with a little bit. If you're going to increase the decay, I would like max increase it 5x. If you're going to decrease it, I would also like max just decrease it 5x. I wouldn't go much higher or lower than that. It's either destructive or has diminishing returns. And then for the learning rate, you could probably even be more sensitive. Like if you want to go and your model's cooking the look too much and you want to make the learning rate a little bit smaller so it doesn't overlearn things, you know, you could go down to like 0.8, and if you want to make it a little higher, you could go like 0.003 or something like that. But ultimately, these as defaults are pretty strong, and there's plenty of other things to play with here, and I think it's good to not get too lost in training all these models like I've done, and better to just start making stuff with them. So this is what I would recommend for training LTX, and I will also post like a config file for this as well. So training 30 models at 500 steps each with gradient accumulation of 4, where each step equals 30 seconds, mean that each model takes 250 minutes, which is almost 4 hours to complete. And so if you're training 30 models times 4 hours, just in the training, not even to mention the downloading and the uploading and the captioning and all that stuff, like just in the training for compute, it's 120 H200 hours. So I think training all of these models was around, to get to the version, 30 or whatnot that I ended up liking the most in combination with each other, was around 200 hours for H200s total. I think I had a cluster of them running nonstop for a couple days. And on top of that, this is a folder of all of the individual parameter tests I did inside of Comfy, with the last one being 2,566. Each of these also takes a minute, sometimes more, especially if you're loading the model weights or changing something early in the pipeline. And so this is a lot of hours in testing, just to ultimately have only made one clip so far. God, there's so much more I could talk about in this workflow, or reviewing every single test and showing, the relationship between all the parameters of the model training versus all the parameters in the workflow, and how they relate to each other, and how they scale and how they don't scale, and blah, 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 blah. But ultimately, I sometimes forget that the reason I'm creating these tools is to make things with them. And so I'm excited to start doing more of the of the writing and the thinking and the imagining that ultimately is the whole reason I do this stuff. And in the meantime, I'm happy to share the tools along the way, and if you want to use them, please go for it. If you have questions about it and you want to dig into something, or something's not working, or you want to learn how to do trainings on your own, or you have a specific question, please feel free to ask me over a DM or a comment or whatever, and I'm happy to respond as quick as I can. I hope you were able to take something from it, and I hope that you can make something with it, and I hope that I can too, or else this was all for nothing. Good night.